Let's solve a problem in a front-end application using Honeycomb's Frontend Observability Sandbox. Our company's e-commerce application has been having some performance problems. The product team is counting on my engineers to keep customers engaged so they can spend money with us instead of leaving the site. And I'm using Honeycomb for Front-end Observability, or HFO, so I know I can help right away. My web-based front-end application was configured to use the HFO Web Launchpad for its Honeycomb dataset. This Launchpad displays many key measurements for my instrumented front-end application tracing data, including core web vitals such as largest contentful paint, cumulative layout shift, and interaction in XPaint, total events by type, largest assets, top 5 endpoints by request count, slowest request by endpoint, top landing pages by session count, and pages with the most events. Right away, I have concerns. In my core web vitals, the yellow and red bars tell me that my customers are having a slow, sluggish, or visually jarring user experience. I need to get to the cause of the displayed problems fast and keep people engaged. I'm looking at the largest contentful paint chart, which explains how long it takes for the largest content chunk on a page to be fully rendered. 25% of my LCP ratings are in the needs improvement category and are taking 2.5 to 4 seconds, and 20% of my readings are in the poor range, taking my users more than 4 seconds to see the important content on those routes. This panel shows as a graph of the LCP value attribute by default, but we can get the actual element name of the worst performing content in the table view. I'll switch to it using the table icon above the right side of the graph. Okay, so the div Featured Products Carousel is taking around 7 seconds to load. That's pretty bad. One thing this table is missing is the actual page that we're on. That div could live in a lot of places. To find out the pages that contain our carousel, I'll use the Web Launchpad's Group By dropdown and select Page. Now, the whole Launchpad is showing data grouped by Page.route, both as a column in each table and a different color in each graph. Aha! The root page has the carousel. Time to talk to the engineers. Maybe there's a better way to show our products, or load less content after the initial render. Switching back to the graph view, when grouped by page, it should be obvious visually that one route stands apart from the others in terms of LCP performance. That blue graph line is indeed for the route of the home page. I can prove it further by hovering over that top line plot in the graph. The home pages are all poor LCP.value readings and take more than 4 seconds to load. For further confirmation, I can compare the other span attributes for poor LCP.value ratings in the root page to all of the telemetry attributes for good and needs improvement ratings by clicking on the red 20% marker and selecting Detect Anomalies, also known as BubbleUp. Now I'm in a Honeycomb query with BubbleUp, returning all data for 10 minutes. Yellow represents poor LCPs in the graph, and blue shows the good and needs improvement values. It looks like there aren't many attributes that are different between the poor LCP values and the rest, beyond the page route. All we know so far is that one of our pages, the home page, takes a massive amount of time to load its content. We do need to fix this, but there are other issues being drowned out by this very strong signal. Let's try BubbleUp again, this time with the needs improvement values. I return to the Launchpad and click on the yellow values for LCP in the bar graph, and again select Detect Anomalies. Now I'm in BubbleUp comparing the attributes for needs improvement LCP values to those in poor and good. And look at what we find. Suddenly, it looks like all pages using slower networks, defined by the attribute network.effective-type, have a slower LCP.value than those on 4G or even many 3G network users. We need to share this query result with our engineers and customer support staff so they can figure out how to get the slow users away from JavaScript applications, or at least warn them that the current application is not designed for their networks. Back in the Web Launchpad, since I know that obsolete networks are clouding our view of LCP, I'd like to remove them from my analysis. I group by page again, and then I use the filter dropdown to select only the 4G network speed. This is vastly better performance. All of our pages are performing well, except the home page. I click on the graph's title, Largest Contentful Paint P75, to do more analysis that applies this grouping and filter. Notice how the graph uses a visualization of P75 LCP.value instead of count. This helps us by looking at analyses of the attribute, not of the count of events. To make this query even more useful for our engineers, I'll filter out that pesky home page by adding a where clause, Page.route not equals /, and I'll re-execute the query. Now all of our LCP values are falling into a good range of around a second. Since we have a ton of product routes that include their ID, I'll sort the overview by Page.route to see others. It looks like cart, cart/checkout, and product are all in good shape. Finally, I'll use the Explore Data tab to look at all of my trace event attributes by expanding the entire event field. For a more tabular report, I'll remove the event field and then use the diagonal arrows in the toolbar to maximize my space. Then I'll add Page.route, LCP value, rating, and element. So let's recap. In just using the HFO Web Launchpad to analyze our Core Web Vitals LCP scores, I found out that Honeycomb is a super fast platform for observing front-end application data, and the Honeycomb Frontend Observability Web Launchpad gives me a great starting point for all sorts of analysis. I learned my homepage carousel is definitely taking a lot of time to load. Maybe our engineers could come up with a better way that isn't so costly. I also found out that some users are browsing our website from very slow networks, and this is a complex front-end application. We need to direct those users to a much simpler, faster HTML-driven site, or encourage them to use a modern device on a fast network. With Honeycomb, I have flexibility to query my data on demand and compare all sorts of attributes using BubbleUp analysis detection, visualizations, groupings, where clauses, and pulling fields in a tabular way from the Explore Data Query tab. I hope you've enjoyed this quick introduction to the HFO Web Launchpad. Now go ahead and start playing with the sandbox.